Bismillahirrahmanirrahim. In the name of Allah, the most beneficent and the most merciful. Assalamu alaikum wa rahmatullahi wa barakatuh. Welcome to the 30th lecture of mathematics. Today our chapter 3rd about logarithm. In this lecture we will complete 3.1 and 3.2. 3.1 is related to scientific notation and you have done this scientific notation in physics chapter 1. Before starting the exercise, let us know what is scientific notation and why we use this notation. Scientific notation is a way of expressing numbers that are too large or too small to be conveniently written in decimal form. It means that if there is a very big number or a very small number like 0.00000017 or 38,00000, 10 or 20 zeros are there in the number. For our convenience, we convert these zeros in the power of 10 and we can write our number in a small way like a multiply 10 raised to the power n. To this, convert all the zeros in the power of 10 is called scientific notation. It may be referred to as scientific form or standard index form or standard form in the UK. A number written in the form a multiply 10 raised to the power n. We convert all the zeros in the power of 10 where a lies between 1 and 10. It means that the value of a will be less than 10 and greater than 1. It means a will be only a single number, a single digit like 1, 2, 3. And after the non-zero digit, we put the decimal and we count the number after the decimal. And according to that numbers, we change the value of 10. And n is an integer. Integer means n may be positive or sometime the sign of the n will be negative. Is called the scientific notation. Exercise 3.1. Question number 1 is express each of the following the number in scientific notation. Part 1, 5700, two zeros are there. So first we write 10 raised to the power 2 because two zeros are there, so we write 10 raised to the power 2. The next step I told you that a will always be less than 10. It means that it will be a single digit. So we put the decimal after the non-zero number which is 5. The first non-zero digit is 5, so we write 5.7. And when you put the decimal in the number, always the power of 10 will increase by 1. When we add the decimal in any number, the power of 10 will increase by 1. Same, if we remove the decimal, then the power of the 10 will decrease by 1. So here we put the decimal 5.7. So in the power I write plus 1. Scientific notation of 5700 will be 5.7 multiply 10 raised to the power 3. Now when you solve by the calculator 5.7 multiply 10 raised to the power 3, you see that your answer will become 5700. Next part is 498 and there are 5 zeros. So according to that, we convert all the zeros in the power of 5, 10 raised to the power 5. In the next step, we put the decimal after a non-zero digit which is 4, 4.98. Now how many number after the decimal? 2, 9 and 8. So we increase the power of 10 by 2 because there are two number after the decimal. So we increase in the power of 10 by 2. 5 plus 2, 7, 4.98 multiply 10 raised to the power 7 is our required answer. Come to the part 3. There are 6 zeros, 96 and 6 zeros. We write 96 multiply 10 raised to the power 6 And when we put the decimal here, the power of 10 increased by 1. 9.6 multiply 10 raised to the power 7. Part 4, 416.9. Now there is no zero, but already the decimal is given. First we remove this decimal and then we simplify the question. I told you that when we remove the decimal, the power of 10 will decrease by 1. So there is only one number after the decimal, so the power of the 10 will become minus 1. Now we have 4169 multiply 10 raised to the power minus 1, but this is not the complete shape of the scientific notation. It is necessary that we put the decimal after 4, 4.169. Now after the decimal, how many digits? There are 3 digits. So we write minus 1 plus 3. I told you when we put the decimal, we add the number. When we remove the decimal, we subtract the number. Plus 3, 4.169 multiply 10 raised to the power 2 is our required answer. Same part 583,000. There is power of 10. The power of 10 is 3. We put the decimal after 8. 8.3 multiply by 10. Because there is one digit after the decimal, so we add 1 in 10. 3 plus 1, 4. 8.3 multiply 10 raised to the power 4. Sixth part is 0.00643. Now our numbers start with the decimal. When we have this type of the situation, we cannot write the answer directly, the zeros in the power of 10. First you remove the decimal and you count the number, that how many digits are after the decimal. Then according to that digits we put the power of 10. After the decimal we have 5 digits. So that's why we write minus 5, because we are removing the decimal from the question. So that's why the power of 10 will be negative. In the next step, we put the decimal after the first digit, 6.43. 10 raised to the power minus 5 plus 2, it will be 6.43 multiply 10 raised to the power minus 3. Same you see part 7 and part 8. The same procedure that we adopt in the previous question. Part 9. How many numbers are there after the decimal? There are 11 digits. So that's why we put 395 multiply 10 raised to the power minus 11. And when we put the decimal after 3, 3.95 minus 11 plus 2, it will become 3.95 multiply 10 raised to the power minus 9. This question is also same, but only in the fraction. This is given, we solve numerator separately and the denominator separately. In the numerator there are 3 zeros. 275 multiplied and raised to the power 3. After the 2 we put the decimal. 3 plus 2 is 5. 2.75 multiply 10 raised to the power 5. Come to the denominator. After the decimal there are 4 digits, so the power of 10 will become minus 4. 25 multiply 10 raised to the power minus 4. We put the decimal after 2. 2.5 multiply 10 raised to the power minus 4 plus 1, which is 2.5 multiply 10 raised to the power minus 3. Question 2. Express the following numbers in ordinary notation. Ordinary notation means we will simplify the power of 10 and we write our number in the form of 0. 6 multiply 10 raised to the power minus 4, because in the power minus 4 is there, it means our number will start with point, with decimal. 0.0006. The power is 4, so after the decimal we write 4 numbers. 6 is already given. To complete the number we put 3 zeros over there. Next is 5.06 multiply 10 raised to the power 10. First we remove the decimal from the question. When we remove the decimal, what will we do? We add minus 2. We remove the decimal. 506 multiplied 10 raised to the power 10 minus 2. It becomes 10 raised to the power 8. It means now we put 8 zeros in our numbers. The next is 9.018. Same, you remove the decimal. After the decimal, there are three numbers. Minus 6, minus 3, this becomes minus 9. Because the power of 10 is negative, it means that our number will start with decimal. We have already 4 digits. It means to complete our number, we need 5 zeros. We put 5 zeros and then 9018. The last part of this, again we remove the decimal, change the power of 10. Now we have, there is no decimal here. We have 7865 multiplied 10 raised to the power 5. In the answer we put 5 zeros. Students, this exercise is very easy, yes? We have complete our exercise 3.1 here and we start 3.2. In 3.2 we have a new article which is about logarithm and logarithm of real numbers. At the back of your book, you have 4 pages. In 2 pages, they mention logarithm, and on the 2 pages, the heading is about anti-logarithm. To solve the questions of logarithm and anti-logarithm, we will use these tables. And I will tell you that how you can see the values in the table. What is logarithm? Logarithm are useful tools for accurate and rapid computations. Logarithm with base 10 are known as common logarithm and those with base e are known as natural logarithm. We have two type of logarithm, base 10 and base e. In our book we will use log 10, base 10, and this is called the common logarithm. You also can see on your calculators there are two type of buttons, log, log, and the other button ln is written there, and they mention e and 10. Log they mention there 10, and on ln they mention e over there. So the value of both logarithm will be changed. So in our book we will use common logarithm which have base 10. We shall define logarithm with base a is greater than 0 and a is not equal to 1. It means that the value will be greater than 1. Question number 1 or exercise 3.2. Find the common logarithm. Find the common logarithm of the following number. We have two parts of any number when we are finding the logarithm. One part is called the characteristic and the other part is called the mantissa. Characteristic will always be a whole number. Either it will positive or negative. It depends the nature of the question. But mantissa of every question must be positive, and this is called the fractional part of the question or decimal part because mantissa always start with decimal. So that's why this is called the fractional part of the question. And the characteristic will always be a whole number, maybe positive, maybe negative, because it depends the nature of the question. And how can we find the characteristic? You will convert your question in the form of scientific notation. After the simplification, the power of 10 is called the characteristic. Either it is positive or negative. And for the mantissa, we will check the table which is given at the back of your book as I told you. And you also have a logarithm table. You can use both logarithm table or logarithm which is given at the back of your book. The first part is 232.92. First we find the characteristic, that what will be the characteristic of this question. You remove the decimal and definitely the power of 10 become minus 2. After the first number, you will put the decimal. Now there are 4 numbers after the decimal. The power of 10 is already minus 2. Minus 2 plus 4, 2. So our characteristic in this question is 2. After simplifying, after convert it into scientific notation, we see that the power of 10 is 2. Now we have the characteristic 2. Come to the mantissa. You see on the log table, the first column is, open your books and see. On page 293, there is a table of logarithm. Columns and rows are given. In the columns, the number are 10, 11, 12, 13. You check the first column. 10, 11, 12, 13, 14. The numbers start from 10, not from 1. And you see the first row. In the first row, the numbers start from 0. 0, 1, 2, 3, 4, 5, 6, 8, 9. And then the heading is mean differences column, and also there are 3 columns, and 1, 2, 3, 4, 5, 6, 7, 8, 9, the values are given over there. How can we check the numbers from the table? In the question, number is given 23292. So first we take the number 23, only 23. See in the log table 23. You find? Yes, this is 23. And now move till 2. 0, 1, 2. This is our required number 3655, because in the question after 23 there is 2. So that's why we check 23 in the column of 2, and we see that the value is 3655. 3655. Now we also have the differences column. After 2 there is 9. In the question after 2 there is 9. It means that now on the same row you move to the difference column and go to the 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. You see in the ninth column we have the entry 17. We have the value 70. This is called the difference. Now we add these two numbers 3655 and 17, 3672. After adding we get 3672, but as I told you in the beginning that mantissa will always start with the decimal, so mantissa become 0.3672. Mantissa become 0.3672. Although there is no decimal in the table, but we put the decimal by ourselves. 0.3672. Now you add the characteristic and the mantissa. When we add these two, we get 2.3672. This is the required log of 232.92. This is the required log of 2.3292, which is 2.3672. Is it clear? Now come to the next question. This is 29.326. 29.326, again you convert it into the scientific notation. After the simplification we see that the power of 10 is 1, and in this question the characteristic is 1. Again the same procedure we will adopt to find the mantissa. The number is 29. You will check 29 in the column of 3. You check 29 in the column of 3 because we have 3 after 29. 0, 1, 2, 3. What is the number? 4669. 4669. And again, because there are 2 after 3, so we see the difference 1, 2. In the difference column, there is 3. In the difference, there is 3, so we add 3 in 4669. 46, 4672. After adding the difference 4672 and we put the decimal here because this is Mentisa. Again we write 1 plus 0.4672. 1.4672 is the log of the 29.326. Come to the third part. Number starts from the decimal and after the decimal we have zeros. When we have the zeros before the number, it means that the characteristic will become minus. And you see clearly when we convert in the scientific notation, the power of 10 is minus 4. It means characteristic is minus 4. Now come to the Mentissa. But there is only two numbers 32. No number is after 32. When we have these type of question, it means that the next number will be 0. And we check 32 in the column of 0. We check 32 in the column of 0 and there is 5051. Because there is no number, so we cannot check and we cannot find the difference of this number. Only we write 5051 and Mintisa will be 0.5051. Symbolically, we write minus 4 as 4 bar. Because in the logarithm, we cannot write negative sign before the number. We put this negative sign in the above the number, that is 4 bar. And we read as minus 4.5051. It means that the characteristic of that number is negative. The fourth part of this question, again the number start with the decimal 0.3206. It means that again we have the characteristic minus. When we convert into the scientific notation, the characteristic will become minus 1. Now is the turn of Mentisa. After 32, we have 0 there. It means we check 32 in the column of 0. This is 5051, but we have a number after the 0 which is 6. It means we also check in the difference column. You see in the column of 6 which value is given 1, 2, 3, 4, 5, 6. 8 is there. So we add 8 in 5051 and this becomes 0.5059. We have 1 plus 0.5059 and this become minus 1.5059. This is our required logarithm. I hope students you will learn how you can find the log from the log table. Question number 2. If log 31.09 is equal to 1.4926, find the values of the following. 4 parts are given to you, but you notice that in all the parts the number is same. 3109, 3109, 3109. It means that our Mentisa will be unchanged because 3109 when we see in the log table and already the answer of that number is given to us, so no need to check these number in the log table. We use a Mentisa same for all the parts, only we change the characteristic over there. You see that in the first part 3.109, in the second part 310.9, in the third part 0.003109, in the last is 0.3109. In all the questions, 3109 is common. Only they change the place of the decimal. It means the characteristic will be same throughout the parts, which is 0.4926. Only we change the characteristic in each part. In the first part, In the first part, 3.109, that I told you that Mantissa will be unchanged in each part. In each part, the Mantissa will be 0.4926 and characteristic will be changed. Now, when you convert 3.109 in the scientific notation, the power of 10 will become 0. It means that in this part we have characteristic 0. The Mantissa will be same, which is 0.4926. Only instead of 1 we write there 0. 0.4926. Come to the second part, 310.9. Again, when you convert in the scientific notation, the power of 10 will become 2, but Mantissa will be unchanged, and instead of 1, we put here 2. 2.1, 2.4926. 2.4926. 1 is not here. The third part, 0.003109. Now we have the characteristic minus 3. Mantissa is same, 0.4926. Only we change the characteristic 1 with minus 3. And in the fourth part, again, characteristic is minus 1. Mantissa is same, which is given in the question. So no need to change the Mantissa because in the question they mention without using tables. It means they already given the Mantissa, only we change the characteristic. So minus 1.4926 is the required answer of this part. Question number 3 is find the number whose common logarithms are 3.5621 and minus 1.7427. Now already logarithm is given and we calculate the anti-logarithm. Anti-logarithm and log, they both are inverse of each other. Like multiplication and division, they both are the inverse operation of each other, same addition and subtraction. In logarithm, anti-logarithm and logarithm, they both are inverse of each other. Now logarithm is given to us and we calculate the anti-logarithm of these numbers. The first is 3.5621. As in this, no need to convert into the scientific notation because we take the characteristic directly from this. The number which is before the decimal, it means that this is a characteristic of that number. In this question, characteristic is 3. Now come to the Mantissa. This is 0.5621. Now Mantissa is 0.5621. Because we are calculating the anti-logarithm over here, so you will see the page, open your page anti-logarithm in the book. The page number is 295. Page 295 and 296, they both are of anti-logarithm. In our question 0.56 and open page 296, you see here all the numbers in the logarithm start with the decimal. The first column 0.50, 0.51, 0.52, 0.01, 0.00, all the numbers in the anti-logarithm table start with the decimal. 0.56, we check 0.56 in the column of 2. 0.56 in the column of 2, 0, 1, 2. This is our number which is 3648. 3648. Again we have 2 after 0.56. So we check in the column of difference. 1, 2. Sorry, we check the difference in column 1. We check 0.56 in 2 and now we check the difference in 1. This is 1. Add these two numbers 3648 plus 1. The number is 3649. Now where we put the decimal, because characteristic is 3, it means that after the 4 numbers we will put the decimal. 1, 2, 3, 4. We write decimal point 0. It's up to you if you want to write point 0 or 3649 is our required answer. Because characteristic is 3. If characteristic is 2, it means that after 3 number we will put the decimal. If characteristic is 1, it means that after the 2 numbers we will put the decimal in the anti-logarithm. Now we have the number 3649. This is our required answer of 3.5621. Come to the second part. The second part is minus 1.7427. Characteristic is minus 1. And again in the anti-log table we have 0.74. Now you will check 0.74 in 2. 0.74 in the column of 2, 0, 1, 2. We have here 5521. 5521, and also we have a number 7. Again check 0.74 in the column of 7. Difference is column, the column of 7. 1, 2, 3, 4, 5, 6, 7. 9 is there in the column of 7. So we add 9 in 5521. This become 5530. 5530, but the characteristic is minus 1. It means that our answer will be point. We put the decimal before the number because the characteristic is minus. So 0.5530 is our required answer. We have question 4, 5 and 6. 4, 5 and 6, these three questions are on the same pattern, but for this we also have, now we have logarithm of real numbers. We have the formula a raised to the power x is equal to y. This formula is equivalent to log to the base a y is equal to x. If a raised to the power x is equal to y, then x is called the logarithm of y to the base a and is written as log to the base a y is equal to x, where a is greater than 0, a is not equal to 1, and y is greater than 0. The relation of a raised to the power x is equal to y and log to the base a y is equal to s are equivalent. It means that we can convert a raised to the power x y in the form of log, and also we can convert log in the form of exponential. A raised to the power x is equal to y. This is called the exponential form. So they both are equivalent. We can interchange them with each other. When a relation is given, it can be converted into the other. Thus, a raised to the power x is equal to y if and only if log to the base a y is equal to x. Logarithm of the negative number is not defined at this stage. 4, 5 and 6, these three questions are of the same pattern. Let's start our question. What replacement for the unknown in each of the following will make the statement true? The first part is log 381 is equal to L. We compare this with the exponential form. According to this, a is 3, y is 81, and x is L. A is 3, y is 81, and x is L. We put in the values a raised to the power x is equal to y. According to this, because a is 3, x is L, and y is 81, 3 raised to the power L is equal to 81. On the both sides, bases are changed. We are finding the value of L, and L is in the power of 3. It means that it is necessary that both the bases will be same. For this purpose, we find all the prime factors of 81, and when you find it, you see 3 raised to the power 4 is equal to 81. 3 raised to the power 4 is 81. Now bases are same, we equate the powers, the value of L becomes 4. The bases are same, so we equate the powers, L is equal to 4. Second part is log to the base a, 6 is equal to 0.5. When we compare this to the exponential form, a is a, y is 6, and x is 0. X is 0.5. When we put the values in the formula, which is a raised to the power x is equal to y, a is already a, so we write a. Instead of x, we write here 0.5, and y is 6. So a raised to the power 0.5 is equal to 6. As you know that we can write 0.5 as 1 over 2. A raised to the power 1, 2 is equal to 6. So base is A and the other side the base is 6. No comparison of two bases. The both are changed. So we take the square of both sides. A 1 by 2 whole square is equal to 6 square. A is equal to 36. To remove 1 by 2, we take the square both sides. 2 and 2 is cancelled and the value of a becomes 36. In the third part, log to the base 5 n is equal to 2. Now we have a is 5, y is n, and x is 2. By putting the values in the formula, ax is equal to y, 5 raised to the power 2 is equal to n. Directly you will take the square of 5, which is 25, and the required answer is n is equal to 25. In the fourth part, 10 raised to the power p is equal to 40. We cannot simplify because already this is given us in the exponential form. It means that we will convert it to the log. We take the log to both sides. P log 10 is equal to log 40. We take the log to both sides. Log 10 raised to the power p is equal to log 40. When you simplify log 40, you can calculate log 40 directly with the calculator. You press the button log and then write 40, then press equal. Then you will see that 1.6021, the value of P is there. 1.6021, the value of P is there. Here students, question 5 and 6, they both are on the same pattern of question 4. So I paste the solution of these question over here. When you do these question by yourself, you can compare your solution with this. In question 5, the first part is log to the base 2 1 over 128. Equation is not given, but you write that let x is equal to log to the base 2 1 over 128, and then you will compare, find a x and y and put the values in the exponential form, and then the same way you will calculate the value of x, which is minus 7, because 1 over 2 raised to the power 7, we change the position of 2 raised to the power 7, so the power of 2 will become minus 7. So the value of x, both bases are same. The value of x is equal to minus 7. In the next part, the question is written as log 512 to the base 2 under root 2. It means that in the question, the base of the log is 2 under root 2. Again, we said that let x is equal to log to the base under root 2 512, and compare the values which is a, which is x, and which is y, put in the exponential form, and after the calculation we see that the value of x becomes 6. Same, all the parts of question 6 are on the same pattern. Because 5 is little bit difficult, so that's why I explained this one to you. If you have any problem in this question or in any method, you can discuss with me in the Zoom meeting, or you can send me the message on WhatsApp. You can discuss with me on WhatsApp. Okay student, inshallah we will meet again with the new exercise 3.3 and 4. You can discuss your queries in Zoom class or on WhatsApp. Okay, Allah Hafiz.